Alright, welcome everybody. We are in section 3.5 and we are learning how to write and graph equations of lines. Alright, now there's two goals in this section. We're going to focus on the first one right now in this video. And that goal is that you will be able to write the equation of a line if you're given either 2 points that are on the line or a point on the line and the slope of the line. Alright, so either given 2 points that are on a line or a point on the line and its slope, then you're going to be able to write the equation of a line. Well, in order to be able to do that, there are a few things that we need to know about. First of all, there are two forms of linear equations that we're going to be using when we're writing equations of lines. Alright? And the first of those is slope-intercept form. And I feel that you're pretty familiar with slope-intercept form of a linear equation, as you've done this before in algebra. That's any equation that's written in the form y equals mx plus b. Now, when an equation is written in that form, there are certain things that you know about the graph of that equation. You know that m is the slope, and you know that b is the y-intercept. So for example, let's say that the equation of a line was written as y equals 2/5 x minus 1/3. Well, the m there is 2/5. That tells you the slope of the line is 2/5. And the b is negative 1/3, which tells you the y-intercept is negative 1/3. And another way of saying that is to say that the graph passes through the point 0, comma, negative 1/3. Alright, most technically, b is the y-coordinate of the y-intercept. That's what you see right here. And the x-coordinate of a y-intercept for any graph is always 0. Alright, so slope-intercept form, y equals mx plus b. We're going to use quite a lot of that when we're writing equations of lines. Now, there's another form that we're going to use as well, which is called the point-slope form. And this is absolutely my favorite form of an equation whenever I'm trying to write the equation of a line. It's the easiest to use. Alright, it works in almost every situation. And here's what the point-slope form of an equation looks like. Alright, y minus y1 equals m times x minus x1. Now I want to show you this really quickly. This point-slope form is really a variation of something else that you use quite a lot. I'm going to write this and then erase it in a moment. Really, point-slope form is just a variation of the slope formula. You can imagine if you take the right side of this equation and you divide both sides by x minus x1, that you would have y minus y1 over x minus x1. The only difference here is we put y2 and x2 instead of y and x. Alright, so point-slope form is really just a rearrangement of the slope formula that you ought to know. So you should be able to remember it. Okay, now when you're using point-slope form, m is still slope. Alright, point-slope form tells you the slope of a line, and it also tells you a point that the line goes through, besides the y-intercept, and that point being the x1, comma, y1. That's on the line. Alright, so for example, here's an equation that's written in point-slope form. And in this equation, you can see two things. First of all, the slope of the line, the m, right there, is 1/4. And second of all, you can see the x and y coordinates of a point that are on the graph. You can see that the x1, well, it says +1 right there, and the y1 is -7. That means that this graph goes through the point -1, comma 7. Alright, you see you're supposed to have x minus x1, and x minus -1 is the same thing as +1, right? And then you see here y minus 7, well, that was what our y1 was. Alright, so slope-intercept form, point-slope form, both very useful in writing the equation of a line. Now let's get right into writing equations of lines. And we're going to do that with several different pieces of information given to us. First, I want to start off by writing the equation of a line if you're given the graph of the line as you see right there. Now, you've got to consider what you know about the line when you see its graph. What we know are our 2 points that are on the line. Now, generally speaking, What I'm going to write down right now is my strategy for writing the equation of a line. Okay? What I'm going to do is I'm going to start by making the point-slope form of the equation of the line, and then I'm going to convert that over to slope-intercept form. It's a little nicer if your final answer is in slope-intercept form. It's not 100% necessary if the directions don't tell you to do that. All right, so start with point-slope form, end with slope-intercept form. Now you can see that I've gone ahead and labeled these 2 points as x1, y1, x2, y2. I just as easily could have switched which was the first and which was the second point, but that's the way I'm going. Now if we're going to write the point-slope form of the equation, we do need to know what the slope of the line is. And so we're going to start off by finding the slope of the line using the slope formula. Which you can see would be -1 minus 1 over 6 minus 1, and that's equal to -2/5. All right, we know the slope of the line. And then when we know the slope of the line, now what we're going to do is we're going to use that slope, and we're going to pick either this point or this point and write the point-slope form of the equation. I'm just going to stick with the point that I've already labeled as x1, y1. And start writing the equation then. Y minus y1 is going to be simply y minus 1. And that's going to equal the slope, -2/5, times x minus x1, and our x1 happens to be 1 here, so x minus 1. There's the point-slope form of the linear equation. And what I said we're going to do with that is then convert it over into slope-intercept form, which just means that we need to get y by itself. That'll make it in the form y equals mx plus b. So, just use a little bit of algebra. Let's distribute the -2/5, and that'll make that -2/5 x plus 2/5 on the right side of the equation. And then we're going to add the 1 to both sides to finish getting the y by itself. So that's y equals -2/5 x plus 2/5 plus 1. Now, isn't 1 equal to 5/5? And then 2/5 plus 5/5 will be 7/5. So we'll get plus 7/5. All right, that's how you write the equation of a line. We're going to do this several more times. So if you need to go back and watch this part, do it. Then see if you can do each successful part on your own. All right, here's kind of the same problem, but with words instead of a picture. I'm telling you to write the equation of the line that's passing through 2 given points, 3, -1, and 6, -4. All right, it's the exact same information we knew about the line in the previous problem, except that we don't actually see the graph. We're still going to start by finding out what the slope of the line is, because we need to know the slope every time we write the equation of a line. So let's use the slope formula with those 2 points. And you can see that'll give you -3/3, which is -1. All right, slope of the line is -1. Now let's pick one of the 2 points that are given to us and treat their coordinates as x1 and y1. I'm going to do that with the 3, -1. All right, so that's going to be my x1, comma y1. And then we're going to go ahead and write the point-slope form of the linear equation. All right, so y minus y1 would become y plus 1 since our y coordinate was a negative. And that'll equal the slope, -1. I'm just going to put a negative sign there. That'll imply -1. Times x minus x1, which is x minus 3. Then again, we just want to go ahead and change this over into slope-intercept form by getting y by itself, which is a couple-step process. We'll go ahead and distribute the slope, which will give us y plus 1 equals -x plus 3. And then we'll subtract the 1 from both sides of the equation in order to get y by itself. And we'll have y equals -x plus 2. Pretty simple process, I hope you're finding. Well, all right, try another one. I want you to do this one without my help, and it's actually a little bit shorter than the previous 2 examples. I hope you see why. Write the equation of the line that has a slope of -4/5 that passes through 5, -2. Pause the video, go for it. First, I hope you see why this one was a little bit easier. You already knew the slope of the line, didn't you? So you didn't have to calculate the slope. All you had to do is go ahead and use that along with the point that you were given to write the equation of the line. So you were able to start off and already say that y plus 2 is equal to negative 4/5 times x minus 5. And then it was just a matter of getting y by itself. There you go. I've distributed the negative 4/5, and negative 4/5 times negative 5 is positive 20 over 5, which is 4. And then subtract the 2. One more example for you to try, which happens to be the easiest of all the examples. It should only take you one step to write the equation of this line. I want you to pause the video, try it out, and then I'll come back and kind of show you a little trick to this one, if you can call it a trick at all. Do it. Now, just as with the previous example, you already knew the slope of this graph because it was already told to you. Now, here's the additional thing that made this even easier than the previous one. You notice that the coordinate for the point that this line is passing through has a 0 for its x-coordinate. What that indicates to you when the x-coordinate of a point is 0 is that that point is the y-intercept. And when you know what the y-intercept is, then you already know the value of b, because it's the y-coordinate for the y-intercept, it's negative 4. And so you can go ahead and directly write this equation in slope-intercept form. You can just go ahead and make it y equals negative 3x minus 4. There's your mx plus b. All right, that's writing equations of lines. There's a couple more tricks that we'll throw in at a later time, but that's the basics of it. I think you got it. See you later.